I'll be taking 5 of the JAMB 26 inequalities question. Question 1. X squared minus 5x plus 6 greater than or equal to 0. Find the values of x, or the range of values of x actually, for which this equation is true. Now, first off, this is a quadratic equation. Our first goal is to find the roots of the equation. Let's go. Solution. Now, to get the root of an equation, I can use different methods, which are factorization. We can use completing square method, or we can use the quadratic formula. In this case, I'm going to use the factorization method. Now, we're going to look for two values, two numbers, which when we multiply, we give us 6, and then when we add, give us minus 5. So those two values are minus 2 and minus 3. So I can say that x squared minus 5x plus 6, all right, is also equals to x squared minus 2x minus 3x plus 6. All right, now we're going to factor out x. So x, in this case, when factored out, we'll have x minus 2. Then we'll factor out minus, what is common between minus 3x and 6? That's 3, right? And if you factor out, you are left with x minus 2. Why did plus change to minus? Because when we expand this, minus 3 times minus 2 is going to give us plus 6. So this needs to change. Since our factor is out minus 3, because minus 3 divided by plus 6 is minus 2. We'll pick 1. So this is now equal to x minus 3. Since x minus 2 and x minus 2 is common, we'll pick that. So these are factors. So I can still represent the question as x minus 3 multiplied x minus 2. You can say it is greater than or equal to 0. Now, this is just one part of it, finding the roots. Obviously, we are going to have to separate this into two. We are going to say that x minus 3, right, greater than or equal to 0, and x minus 2 greater than or equal to 0. Okay, and which, of course, here we will obtain x greater than or equal to 3 or x greater than or equal to 2. Come on, answer x greater than or equal to 3 or x greater than or equal to 2. No. The question says if you find the range of values of x for which this expression x squared minus 5x plus 6 is greater than 0, greater than or equal to 0. When something is greater than or equal to 0, it's either be equal to 0 or it is greater than 0. Something that is greater than 0 must be positive. So the question is simply asking that we should find the range of values of x for which this expression is positive. Now, there are two kinds of quadratic equation. One of them, or we can represent quadratic equation in two types. One of them is when the coefficient, let me call this case 1. So case 1 of quadratic equation is when coefficient of x squared is greater than 0, which in that case it is positive. So the coefficient of x squared, right, is equal to plus VE, which is positive. And the second case, case 2, is when, right, the coefficient of x squared is negative. Now, for this question, we obtain our roots as greater than 3, greater than or equal to 3, or greater than or equal to 2. Now, since x squared, since the coefficient is 1, is positive, we're going to use case 1. And what does case 1 involve? To find the actual root for case 1, x, alright, greater than the bigger root. The bigger root between 3 and 2 is 3. So x must be greater than, or in this case, greater than or equal to, since it can also be equal to 0, greater than or equal to 3, or x less than the smaller root. So x less than or equal to 2. Now, the reason why using this equal to indicates that when you put 3 or 2 into the equation, you are going to obtain 0, which is this greater than or equal to. But meanwhile, since the coefficient of x squared is positive, we apply this rule that x, it the quadratic equation will become positive when x is greater than the bigger root or x is smaller than the smaller root. And for any value for which x is greater than 3, let's say you have 4, you have 5, if you implement this equation, it must be positive. What you may obtain will be positive, greater than 0. If you implement a value less than 2, it will still be positive. All right, but meanwhile, when the coefficient of x squared is negative, it becomes x. All right, let me write it here: x greater than, we have, for the equation of value of x now to be positive, we have x should be greater than the smaller root, x should be greater than the smaller root, or x less than the bigger root, or x less than the bigger root. So for that range of values, the answer will, the equation rather, will be positive. Our answer will be positive. So for this question, x greater than or equal to 3 or x less than or equal to 2 become our answer, which corresponds to option A. An equation 2x minus 1 divided by x plus 3 greater than 1. Obviously, we have to find value of x for which this equation is greater than 1. A, x less than minus 3 or x greater than 4. B says minus 3 less than x less than 4, minus 3 less than x less than 4, x greater than 4, and we have x less than minus 3. Alright, first off, we are going to equate this expression to 0 so that we can find the LCM and express this as a single fraction which is greater than 0. Then we can then find values of x for which that equation is positive, similar to what we did for question 1. Let's solve. Alright, so the solution, that becomes 2x minus 1 to make it equal to 0 over x minus 3, x plus 3. To make it equal to 0, so I'm going to take 1 to this side, so that becomes minus 1 greater than 0, right? So first, let's simplify this fraction. We have in x plus 3. X plus 3 is the LCM between, since here has the denominator as 1. So x plus 3 divided by x plus 3, that's 1. 1 multiplied by 2x minus 1 remains 2x minus 1. Alright, minus x plus 3 divided by 1, that's x plus 3 times 1 remains x plus 3. So you have minus, you can bracket x plus 3, right? So simplify this will become 2x minus 1 minus x minus 3, all divided by x plus 3. So we have 2x, we have minus x, we have minus 1, we have minus 3. So these are common terms. 2x minus x is equivalent to x minus 1 minus 3, that's minus 4 divided by x plus 3. So we equated our fraction to 0 by saying that x minus 4 over x plus 3, right, is greater than 0. Now our goal now is to find the values of x for which this fraction is positive. The equation we had, right, x minus 4 divided by x plus 3 greater than 0. To find the value of x for which the equation is positive, we must first identify critical points. Now, what are critical points? Critical points, they are values of x. First, like this. So identify critical points, which are values of x for which the equation is two things. What are those two things? One is for which the equation is 0, that's the equation is equal to 0, and the equation, and also it is undefined. Now you can identify critical points basically by looking at the equation itself. An equation is equal to 0 when the numerator is 0, and it is undefined when the denominator is 0. So for the equation to be equal to 0, we can say that when equation is 0, meaning that x is equals to 4, right? So the equation will be equal to 0. Why? Because 4 minus 4, that's 0. 4 plus 3 is 7. 0 divided by 7 equivalent to 0. While for the equation to be undefined, we must have that denominator is equal to 0. So equate x plus 3 to 0, and x becomes minus 3 by collecting like terms. or x is equals to minus 3. Now these are the critical points. Now the equation, remember our question is we're looking for value of x for which this expression is greater than 0. So we're simply going to try values greater than or less than 4 and also greater than or less than minus 3 and see which of them will give us a positive fraction. Now let's take a value greater than 4. Let's say 5. For example, now let's say you have x, right? X, for x greater than 4. Okay, we also take x less than 4, then, or we'll take x greater than minus 3 and x less than minus 3. So let's try. Now for x we have 4, let's just say 5. We'll have 5 minus 4 over 5 plus 3. 5 minus 4 is equivalent to 1. 5 plus 3 is 7. 1 divided by 7 is a fraction which is greater than 0. Why? Because it is positive. So this gives us 1 over 7. So meaning that when x is greater than 4, our expression is positive. That's one of our values of x greater than 4. Sorry, x greater than 4. Let's do the same for x greater than minus 3. So we don't need to test out x less than 4 since we already established that x is greater than 4. So mean that for values for which x is less than 4, this expression will be negative. Let's try x greater than minus 3. If value greater than minus 3, we have minus 2 minus 4 over minus 2 plus 3, right? If you observe, minus 2 minus 4, this is equals to minus 6 minus 2 plus 3, that's 1. This is negative. We're looking for values for which the equation is greater than 0, positive. So x greater than minus 3 cannot be one of our answer. So let's try out x less than minus 3. We would have the value less than minus 3 will have minus 4 over minus 4 plus 3. Minus 4 is minus 8. Minus 4 plus 3 is minus 1. Negative cancels, negative will give us positive, and 8 divided by 1 is equals to 8. So this is one of our values. Alright, so x greater than 4 or x less than minus 3. That becomes our answer. It says solve 2x plus 7 greater than 5x minus 2. So we're going to find the value of x for which this equation is true. So let's solve the solution. Now we're having 2x plus 7, right, is greater than 5x minus 2. I'm simply going to collect like terms and say that 2x minus 5x, alright, 2x, just write it out, 2x minus 5x should be greater than minus 2 minus 7. So this is equals to 2x minus 5x, which is now minus 3x, greater than minus, we had minus 2 minus 7, which is now minus 9. Yes, so we divide both sides by minus 3. Dividing both sides by minus 3, we'll obtain that x, the sign will change, should be less than, change from greater than to less than, so less than 3. That corresponds to option A. Question 4. Given that x is an integer, find the possible values of x satisfying 2x plus 5 less than 3x minus 1, x squared minus 3x minus 4 less than or equal to 0. And we're giving 4 options. Now we're going to find the values of x for which this equation is true. We're going to find the values of x for which the equation is less than or equal to 0. Okay, and then we're going to find where those values of x are common. That's the common values, the intersect between them, the common values of x in both equations. So let's go solution. Now the first thing, let's solve this equation first. Solve this equation, right? So we have 2x 5 less than 3x minus 1. Now simply say that we'll collect like terms, right? So 2x minus 3x, that becomes, so this is equal to minus x less than minus 1 minus 5, that becomes minus 6. Dividing both sides by minus 1, we'll have, of course, the sign flips because we are dividing by a negative sign. So this is now equal to x greater than 6. Now x greater than 6 implies that x can take values such as 7, 8, 9, 10, to infinity, right? But definitely not equal to 6 or less than 6. Now let's solve this. This is a quadratic equation. We have x squared, a quadratic inequality, rather, x minus 4 less than or equal to 0. Now the first thing we did, as we did before in the previous video, is to find the roots of the equation. The root of the equation, we've already pre-solved this. You can use the quadratic formula for ease. The roots are x. We have x minus 4, x plus 1 less than or equal to 0, right? So now remember, we're going to split it. Say that x minus 4 should be less than or equal to 0, or x plus 1 should be less than or equal to 0. Here we would have x less than or equal to 4, or x less than or equal to minus 1. But this is not our answer. These are just the roots. Now when something is less than or equal to 0, it simply implies that it is either equal to 0 or it is negative, because values less than 0 are negative, values greater than 0 are positive. Now since the coefficient of x is positive, it was 1. So previously we said that to find the values of x for which the quadratic equation is positive, we say x is greater than the bigger root or x less than the smaller root. In this case, the equation is negative when, so you can see that x squared minus 3x minus 4 will become less than or equal to 0 when x, you have to take note now, x, right, I'm going to put it in the middle because it's a range, a fixed range. X should be less than the bigger root. Now what was the bigger root in this case? The bigger root, which is 4, x will be less than, we include equal to, since when x is equal to 4 we can have to obtain 0, and x should be greater than the smaller root. So x greater than as well equal to minus 1. So this is because our range of inequalities minus 1 less than or equal to x, x less than or equal to 4. Now the values of this range simply implies minus 1, 0, 1, 2, 3, and of course 4. These are the values for which this equation is positive. Then for which this equation is positive, values are 7, 8, 9, etc. Now there is no common value. Minus 1, 0, 1, 2, 3 is never equal to 7, 8, 9. The reason that this is fixed, this will continue increasing, and it has passed 4, so it will never come back. And then the correct answer to this question is that there is no intersection. It's an empty set. Correct answer is A, no solution. Solve the inequality 2x squared minus 5x minus 3 greater than 0. This is a quadratic inequality similar to what we saw before. So we'll find the root of the equation and then find the region for which it is greater than 0, that is positive. So solution. We are doing this to solidify the knowledge we did for question 4. So solution. Now 2x squared minus 5x minus 3 is a quadratic equation. Ordinarily we'll look for values of, we look for two values. If we multiply them, it will give us minus 6, and then if we add them, it will give us minus 5. Now since the coefficient of x squared here is no longer 1 but 2, we have to find the product here and here, which is minus 6. Now what will you multiply? That will give you minus 6. Well, and that same thing, if you add them, it will give you minus 5. You can think about it. Alright, so the actual reason is that the answer is not 2 and 3, but there is no value that when you multiply you get minus 6, and then when you add you get minus 5. So obviously we cannot use the factorization method, but rather we use the quadratic formula, which is also known as the almighty formula. Now we've introduced quadratic formula in our previous video, so I'm just going to go straight to the point. So this quadratic formula generally says that x, values of x for a quadratic equation is equals to minus b plus or minus square root of b squared minus 4ac divided by 2a, right? So you know what b, a, and c represent. So minus b, that becomes 5 plus or minus the square root of b squared, that becomes 25 minus 4, 2 in bracket 2, and c is minus 3, all divided by a is 2. So we would have 5 plus or minus, if we simplify what's inside this square root, 4 times 2 is 8, 8 times 3 is 24, so that's minus 24, 25 minus 24, that gives us 49, right? Divided by 2, multiplied by 2, that's 4. All right, we have that is equals to 5. The root of 49 is 7, so we have 5 plus or minus 7 divided by 4, right? So 5 plus or minus 7, this is equals to x, so mean that x is equals to 5 plus 7 divided by 4, or 5 minus 7 divided by 4. Now x will now be equal to 5 plus 7, that gives us 12, 12 by 4 is 3, or 5 minus 7 is minus 2, minus 3 divided by 4, that's minus half. Alright, now find the region for which is positive. Remember, we said that this is the bigger root and this is the smaller root, so it will be greater than the bigger root for a quadratic equation where the coefficient of x squared is positive, and you have to find the region for which is positive. X should be greater than the bigger root, which is 3, so we should say that x should be greater than 3, or x will be smaller root, so x will be less than minus half. That corresponds to, which option do we have here? That's right, option A. And that's it.